You pack a box, attach a shipping label, and hand it to a carrier.
Seconds later, the box leaves your sight, and most of its journey becomes invisible.
What actually happens from that moment until it appears at the recipient's door? The answer begins not with distance, but with the system identifying the box correctly. A shipping label gives the package an identity a machines and people can read.
But creating a label does not necessarily mean the carrier has received the package.
The next key moment is when the box physically enters the carrier's operating network.
From there, the physical box and its attached data begin moving in parallel. The box has a destination, but the system must also know what comes next.
Scans at different network points help create that chain of information. After acceptance, packages are usually grouped and moved toward an appropriate processing facility. This is where one package joins a flow far larger than itself.
It stays individually identifiable, but now moves inside a much larger shared flow.
It becomes part of a network coordinating thousands or millions of different destinations. At sorting, the label must be read accurately enough to determine the next step.
Barcode and shipping data connect the physical box to its destination and service. Once that information is read, it can trigger an immediate physical decision. A sorting mechanism can redirect the package to another lane, belt, or processing area.
What matters is not the machine's name, but the decision it makes in the flow.
Each redirection moves the box closer to packages sharing the same next journey.
That is why large networks do not send every package separately to every city.
Packages heading in compatible directions are grouped to share the next transport segment.
Consolidation lets networks move huge volumes without one vehicle for every package.
Once a load is built, the package is ready to leave the first facility. But the next leg is not the same for every package. Depending on carrier, service, origin, and destination, it may travel by road or air. So fast delivery does not necessarily mean the package has to fly.
Even when air is used, it is only one part of the larger network.
For many packages, long-haul trucks are the main link between processing facilities. Either way, the middle mile moves large volumes to the next node on time.
That idea of nodes explains why a package may appear to take a detour.
Parcel networks are not built as millions of direct lines between every address pair. They use hubs and transfer points to consolidate, resort, and redirect traffic.
So a package may pass through an intermediate facility before reaching its destination region.
There, the package is identified again and sorted for the next part of its journey. The same basic logic may repeat at another facility, but at a different scale.
That repetition is not wasted motion.
Each node answers a new question. Which group should this box travel with next? This is where data matters more than the visible conveyor belts.
If the system cannot identify a package and its destination, machine speed means little.
A scan event can record arrival, departure, or movement into a new processing stage.
Those events create much of the journey senders later see in tracking.
Tracking should not be imagined as continuous GPS inside every package. Instead, tracking usually reflects discrete events recorded at points across the network.
What you see on screen is a digital shadow of the physical journey.
That information helps the network place each shipment within the operating flow. It can also support load assignment and the next routing step.
At this point, the story is no longer just boxes moving on conveyors. It is coordination among goods, machines, vehicles, data, and people. Scale makes that coordination necessary. Pitney Bowes estimated the U.S. market handled about 23.1 billion parcels in 2025. That works out to tens of millions of parcels on an average day. At this scale, even small decisions must be repeated enormous numbers of times. So sorting speed is only one part of the operational challenge. A quickly sorted package can still lose time if it misses the next departure. That is where a key network constraint becomes visible. The package must be processed correctly and be ready at the right time. A trailer, line haul movement, or air leg may have a scheduled departure window. If the package misses that window, earlier speed cannot create another departure. Parcel logistics is therefore a timing problem across many connected points, not one sorter.
The pressure grows when volume rises, and several parts of the network get busier.
Then space, labor, vehicles, and schedules can become constraints alongside sorting equipment. A large system needs capacity across many links, not just a faster machine. Large hubs show this scale clearly, but they are examples within different carrier networks. FedEx says its Memphis World Hub can process up to 484,000 packages per hour. That is published capacity for one facility, not actual hourly throughput across the U.S. industry. The figure matters because it shows how much flow one node may need to handle. Even in highly automated systems, not every parcel follows the standard automated flow. An unreadable barcode can prevent the automated system from making its normal routing decision. An oversized or irregular package may not fit the standard conveyor flow. A damaged package may need to be separated for inspection before continuing. Cases like these show why people still matter inside the network.
Receiving, operations, maintenance, exception handling staff, and drivers protect or redirect the flow.
Automation speeds repetitive work, but it does not eliminate people from the entire network. After an exception is resolved, the goal is to return the package to the correct flow. Meanwhile, a normal package continues through nodes toward the destination region.
When the package reaches the destination area facility, the journey begins to shrink in scale.
Earlier, the box moved through routes between facilities and large package flows. Now the system must turn it into a delivery task for one specific address. The package is sorted into the appropriate last-mile area or route.
From here, thousands of network miles can shrink into a route through a few neighborhoods.
The driver receives a group of packages arranged for that local route. This is where a national network reconnects with the recipient's familiar streets.
After scans, sorts, consolidation, and transfers, the box becomes one package for one address again.
If delivery succeeds, a final event updates the journey's status.
If delivery fails, the package may enter redelivery, pickup, or another carrier-specific process. Exact procedures vary by carrier and service, so no single path fits every U.S. package. But the core logic of large parcel networks is still easy to see.
First, the system must know exactly which package has entered the network.
Then its information must create a decision about where it goes next. Packages with compatible journeys are grouped to use larger transport segments efficiently.
At later nodes, they are identified again and routed through the remaining network.
Each handoff must be accurate and timely enough to catch the next movement. A transcription features a single speaker, an adult American male narrator with a warm, medium-low baritone and a...
That is why a package looks simple on screen, but is far more complex behind it.
You see a few tracking lines. each reflecting a real change in package status or location.
You see an expected delivery date, while the network coordinates many decisions behind it. And you see one box at the door after many vehicles, facilities, and sorts. So a package does not really travel from sender to recipient in one trip. It moves through a chain of nodes, where data guides each next physical movement. Coordination between those two journeys lets billions of parcels coexist within one network.
One journey belongs to the box. The other belongs to the information guiding it.
Next time tracking shows a new scan, you will know another network event was recorded.
And when the box reaches the door, you are seeing the final step of that system.
Thank you for joining Industry Unseen to follow the hidden journey behind an everyday package.
We'd be glad to have you like, subscribe, and join us for more hidden everyday systems.